Hello, today we are going to discuss a very important question, which is called the Basel problem. So this is 1 over n squared, the series, sum of this 1 over n squared series. So it is 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square, so on. So similarly, this is a inverse square law. So this sum of this series is equal to pi square by 6. This is calculated by Euler in 1734. So today we will discuss the solution by different method, by which is called Cauchy's solution. So take a circle. So this is a circle centered at A, and it has 2 points at the circumference B and C, and there is another point away from the circumference, which is at D. So that the area of a small triangle ABC and area of a big triangle ABD. So we arrange this one. So the area of a small triangle ABC is less than the area of the sector, which is ABC. ABC. This sector has in area A of the small triangle plus this red area, red region, and this is less than the area of the big large triangle ABD. So the area of the small triangle, so this is the height, which is small d, and this is the height of the large triangle, which is capital D. So this area of the small triangle, so if you calculate this one, D is equal to R sine theta, and capital D is equal to R tangent theta. If you substitute this value, so this is equal to half R squared sine theta is less than half r square theta and is less than half r square tangent theta. R squared by 2 cancelled, so we have this identity. Sine theta is less than tangent theta, where theta lies in between 0 and 2 pi. So this is the first step. Then we will use some trick. So the trick is that this is the inequality. So we will take a reciprocal and square it. So 1 over sine square. So now the sign will change from the less than to larger. So this is larger than 1 over theta square is larger than 1 over tangent square theta. So simplify this one. This is a cosecant theta. 1 over theta square, it is cot square theta. So change the position. Cot square theta is now less than 1 over theta square is less than cosecant square theta. Trigonometric identity, cosecant square theta is equal to 1 over cot square theta. Substitute this value here. And now we have defined the theta in terms of n. So this uh, is equal to n pi over 2n plus 1. So where n is small n is the running value and n is a fixed value. So it's in between this one. So we just substitute the value of theta in this one in here and here and here. So we have substitute this value. But now we have to take one thing, that we want just 1 over n square in the middle, and the rest the terms we have to multiply throughout this expression. If you multiply throughout the expression, pi square over 2n plus 1 whole square, and then we will have a expression. This is the expression which will come from after this one, after this one. So this expression is pi squared over 2n plus 1 cot squared and angle value this one. 1 over n square is less than, this is 1 plus those are the two terms, this one and this one. So now we will operate the sum of all the terms. If you put to summation, so this will summation will operate here, and this operation will operate here, and this operation will operate in twice here and here as well, where there is a small n value. So if you look at again, so we can have this one, and here this is a constant value pi square. So it will be sum of pi square, pi square, pi square. So n times. So this will be n square pi square. So n n time pi square over 2n plus 1 whole square. So this will be separate term, and this summation will operate here because small n is here on the top value, this one here. So this one, so this n on top and n square on the bottom. So this n is large, so this will tend to 0. So if it is 10 to 0, we have only one term here. So this will be one term on the on left side, one term on the right side. The only problem is that we have to find the value of cot square. Cot square here, cot square here. So that we have to find this one. Now there is now we have another trick to use this one. This is a complex number. So we will use a complex theorem. The De Morvey theorem, which is called, and which is very important, this is a cos theta plus I sine theta raised power n is equal to cos n theta plus I sine n theta. So inverse of this one is equal to, because we want cot, so we have to divide by sine raised power n. So this term is equal to this term. So this is equal to cos theta plus I sine theta over sine theta whole raised power n. So this is equal to, if you simplify, this one is a cos theta. So this is, if you simplify, this one is a cos theta over sine theta plus sine theta over sine theta whole raised power n. This is 1. This is I, and this is cot. So cot theta plus I raised power n. So this term, this left hand side is this one, and right hand side is the binomial theorem. So binomial theorem, we can expand this one. Cot theta plus I raised power n, n0, n1, n2, nn minus 1, nn. These are the coefficients of the binomial theorem. And this is a cot raised power n theta, first term, first, and then this is a cot square n minus 1 into I raised power 1, and this one cot n minus 2 and I squared, and 3 cot n minus 3 and I raised power 3. So similarly there will be terms. So there will be some this is a real term because there is no I. This is an imaginary term because it has I. This is have I squared, which is a minus 1. This is a real term, and this is I cube. This is minus I. This is a real imaginary term again. So there will be some real terms. So this will be imaginary term. So separate them into real and imaginary part. Similarly, in here, this is a two parts. So this is equal to okay. This is a cot theta plus I sine I. Yes, it's from here. So it is equal to this one. So now we will have another thing. This is imaginary term. So imaginary term is with the sine is this one, sine n theta over n sine theta raised power n is, if it is 0, it is 0 only this condition when theta is equal to n pi over 2n plus 1. Suppose if n small n is equal to 2n plus 1, so if you substitute this one, this is equal to pi sine n pi, which is always 0 when n is equal to 1, 2, 3, so on. So we have on the left hand side is 0, and right hand side we have imaginary part, which is this thing. So now we have to find the value of the cot. So we know the angle is theta, n pi over 2n plus 1. So that we have to find the what is n minus 1, what is n minus 3. So if you substitute this value, this is n, small n is 2n plus 1. So 2n plus 1 1 here, and this one 2n plus 1 3, and this is a cot of n minus 1 is 2n, and n minus 3 is 2n minus 2. So this will be cot 2n and cot 2n minus 2. So now slightly is another way. So suppose cot squared is equal to t. So t raised power n is equal to cot of 2n theta. And similarly, cot of n minus 1 is a cot of 2n minus 2. So which is this term. So if it is this term, so then we can simplify this in further. So we know that this is equal to, left hand side is equal to 0. Suppose this is a polynomial of ft, which is 2n plus 1, 1, this is the coefficient, binomial coefficient, and to t raised power n, and 2n plus 1 by 3, binomial coefficient again, tn minus 1, and plus so on. So this one, so this is a polynomial, so we can have used this by the formula, which is a generalized formula. Suppose this we have a quadratic form polynomial, quadratic equation, ax squared plus bx plus c. So there's they have two roots, x1 and x2. If the true roots are x1 x2, sum of the two roots is equal to minus b over a. B is the second term, and a is the first, b is the coefficient of the second term, a is the coefficient of the first term, so with the minus sign. So this one, this is a Witia theorem, is that the sum of any polynomial will be equal to minus the second coefficient and divide by the first coefficient, uh, so that the sum of the all the roots of this equation is a tn, which will be equal to minus and minus of this coefficient minus 2n plus 1 3, and divided by the first coefficient 2n plus 1 1. So this one minus 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 plus, so this is the binomial coefficient divided by the other coefficient. Generally nk, n factorial into over k factorial multiplied by n minus k factorial. This is the formula. We have to solve this sum of the roots. If we solve this one, so this is sum of the all the roots. So this one will be equal to 2n plus 1 factorial divided by 3 factorial into 2n minus 2 factorial. Similarly, 2n plus 1 factorial, and the difference is 2n factorial. So this 2n plus 1, 2n plus 1 cancel. So we are left with 1 factorial, which is 1, uh, into 2n factorial into 2n minus 2 factorial. 2n factorial can be written as a 2n minus 2 factorial, as if it is this one. So we can write down 2n minus 2 factorial, and we can use these two terms. So two terms, so divided by 2n minus 2 factorial at the bottom. So this is cancelled. We are left with this 3, 1, 2, 3, 4 term. So this is equal to 1, and 3 factorial is 6, 2n multiplied by 2n minus 1 over 6. This is the sum of the root of the tn. But tn is, t is equal to cot squared. So theta is equal to n pi over 2n minus 2n plus 1. So this one, so if we have tn, so this one is uh, all the roots. So this value, so you've put the value of the theta. So this is equal to cot square n pi 2n plus 1. But this says is equal to this one, is equal to this one. So this term on left hand side is equal to 2n into 2n minus 1 over 6. This is the 8th step. This is very, very important step. So this one will give us the right solution. Now we substitute this step 8 into step 3, which was the previous equation, where we have told you that we want to find out the value of the cot theta on left side and the right side, if you substitute the value of the cot theta, which is 2n and 2n minus 1 over 6 in this side and also in this side. So we will have this uh, cot square, this one, f and multiply by this one. So you will see that this is pi square by 6 here on the right side and pi square by 6 on the left side. And other side, if you limit, if you take this one out and operate the limit and take this one uh, out here, so and operate the limit, so this is less than and 1 over n. So this will be n square and this is n square. So the coefficient of the larger term is the same as up and down. Here also coefficient is the same. If coefficient is the same, then it is the whole terms is can be approximated as 1. So this is 1, this is 1. So we are left with the pi square on left side and pi square on the right side. So this is, that means that is only one possible solution, which is equal to of this series 1 over n square is equal to pi square by 6. This is the answer.